Okay, number 98 is another stoichiometry problem. Again, we know that because we've got information about hydrogen gas and asked about zinc chloride. Okay, so given information about one thing, asked about another, I know I have to do stoich. And when I know I have to do stoich, I need to balance my equation. So this is saying I want to produce hydrogen gas. So I know that's a product by reacting zinc with hydrochloric acid. So I've got zinc and hydrochloric acid. So this is going to be a single replacement reaction because zinc is a cation, hydrogen is a cation. The hydrogen ends up alone. It's a diatomic. And then the zinc goes with the chlorine. Because zinc has a positive 2 charge and chlorine is -1, it's going to be ZnCl2. So I just need to balance that by putting a 2 here. So now I'm ready to start my tracks. Again, always starting with what we know about in the question, which here is our 15.00 grams of hydrogen gas. Okay, so that means diagonally I'm going to have grams of hydrogen gas, and therefore I know that there are 2.016 grams of hydrogen gas per 1 mole. Okay, that's our molar mass for hydrogen. Remember, we need to take 2 times 1.008 because of that little subscript 2. Then I look back at my balanced equation, right? I'm given information about hydrogen and I am asked about the zinc chloride. Okay, so if I want to produce 15 grams of hydrogen, how many grams of zinc chloride will also be produced? Okay, so those are actually reacting in a 1-to-1 ratio. Even though it's 1-to-1, we still need to include it in our work. Okay, and then the last step is to convert that zinc chloride back to grams using its molar mass, which is going to be 136.28 grams of zinc chloride. Because don't forget to be careful with those significant digits. We've got 4, then 4, and then 5. And so our final answer can only have 4 significant digits. When we plug this in, we're going to get 1014. But remember, when a number is greater than 1,000, we go ahead and we put it into scientific notation. So the actual answer is going to be 1.014 times 10 to the 3rd grams.